Yes, we can. Sorry, I don't know why I'm being weird and hesitating. All right, here we go. 3. So you've got this system. It's kind of the same deal. And so we know that this guy has a force of gravity of 250. We'll do this quick, you guys. Listen up. This is 350 newtons. You found the acceleration of the system and got 1.63 meters a second squared. Is everybody cool with that? All right. So question C and D ask for the tension forces on the two things. So first of all, do you guys understand they should be equal? And is everybody good with how we found this acceleration? Yes?
Is it okay if, like, in our answer, if they're like slightly off?
They're going to be a little bit because of rounding.
Okay.
Yeah, totally. Yeah, because this acceleration is rounded. So, all right. So everybody get up to there. All right. So I heard somebody say they got C but didn't get D. You thought? Was that you? Okay. So let's do D. C is the same thing. So let's do the tension on M2. Oh, I think I know what you did wrong, Carla. So here's my M2. I know the force of gravity is pulling it down with 350 newtons. What's the other force on it? Tension. You good with that, Adam? Okay. Now, what's the acceleration of this thing, you guys?
1.63.
I agree-ish. It's accelerating down, isn't it? Because that's the heavier one. So that acceleration, even though my system, you probably decided, all right, for my system, I'm going to make this way positive and this way negative. That sign convention only applies to the system. It does not apply to the individual objects. All right? So my individual object over here is accelerating downward. That means it's a negative acceleration produced by the negative force of gravity. Was that what you missed, that negative sign? Adam, are you good up to there?
Yeah.
All right. So then our next step is just net force equals net force. So let's see, my mass. Oh, stupid, we don't know the mass. So our mass is just 350 over 9.8, right? Is that cool if I cheat and do that?
Yes.
All right, our acceleration is negative 1.63. And that's got to equal our force of gravity plus the tension force. And then you solve it. Good?
Yeah.
So I don't mean this. Where did you get tangled up? Like what was...
Like, I was thinking about how M1 was pulling down with 250, and then M1 was being pulled down with 350. So I drew like my free body diagram, and I drew like 350 down and 250 up.
Gotcha.
That would make sense.
I gotcha. Yeah. So the tension force, this block, even though there's 250 newtons on the other side, this block doesn't receive that full 250 newtons. It's probably worth talking about why. Okay? So remember, the tension at both ends of your string is the same. So the tension here equals the tension here, right? So if you're telling me, for example, that this tension is 250, then that also means that this tension would be 250, which produces a contradiction. Why is that a contradiction, Adam? Do you see why?
Yeah, because then it wouldn't be moving.
Because then this one's not moving, but this one is. But they're tied together, so they have to be moving. Follow?
Yeah.
Cool?
Yeah.
Everybody good? All right, so we want to do oh, yeah, sorry.
If you know that tension's going to be the same, can you just solve for one?
100%, yes. The only time I would say to solve for both is A, if you have extra time, and B, well, and the reason why you would do that is because then you can sort of check your answer and make sure that everything jives. Good? But yeah, on a test, like if you're tight on time, if you find one of the tensions, then just go, and the other one's the same. All right. Good? Cool. Unless the problem specifically says to do it. Do you know what I mean? Like I know last year on an honors test, I wrote, calculate the tension, and then the next question said, find another way to find the tension, and, check your answer, or something like that. Okay? All right, everybody good? Okay, so